saw in the previous class how to actually do this by converting this into specifications. So you develop the metric for converting the customer needs into the product specification. So this was what we discussed in the last class. How do you develop a specification for a product? The design specification for a product by converting the subjective customer needs. We know that the relatively subjective customer needs can be converted to objective design specifications. So the first step in the design is to convert the customer needs, subjective customer needs, into objective design specifications. And when we do that, the specifications should be a quantitative thing. You should be able to quantify whatever you say in the specification. You should be able to quantify it. You should be able to measure it, and then you should be able to satisfy this in the design. So that is basically known as the specification. The specification has got two components. One is known as the metric. The other one is the value. So every specification, you should be able to identify a metric and a value. And the understanding is that if you can convert the customer needs into a metric and value, then you can do a design to meet the metrics. So that is why we convert all the customer needs into specification with a corresponding metric and a value. So how do you identify the metric for every need is the challenge, or that is the task to be done by the designer. So you have a customer need like it should be lightweight, or it should be easy to use, easy to assemble, less time to operate. So all these things are customer needs. Now we have to see how do we actually convert that into design metric or design specification. So when we do that specification, what we get is a target specification. That is, what is our target? What is that you want to achieve? When you say it is easy to use, you will say, okay, the number of components should be less than 2. That is your target. But then you can have finally after all these things, because there may be conflicting design requirements. At the end of all this, you will find out what is the final thing that you can achieve by considering multiple requirements. Each requirement you can get a target specification, and then looking at all those requirements, you will be finding a final specification. This is what is done in developing the specification. So the steps involved in developing the specification are this, which we mentioned in the last class. First thing is to see how to prepare the list of metrics. What are the metrics that you can identify corresponding to each need is the first step. And once you do this, then we find out how to get the value of that metric. And the value comes from benchmarking information. So what is being done in other areas, other products, what value they are using, that will be used to identify the what value to be used in their products. And then we set the ideal and marginal value. So ideal something will be there, but acceptable or marginally acceptable values also there. So we make it as marginally acceptable values. And then analyze these results and then see which one is going against each other. There will be a requirement that it should be low cost, and there will be a requirement that it should be durable also. So there are two requirements. One is it should be low cost, the other one is it should be durable. These are actually not going together. When you make it more durable, the cost can go up because of the material you use, the production method you use. So how do we actually overcome those issues are basically reflecting on the results. So first we look at the preparation of metrics and how do we actually start the metric conversion. So why we are actually doing this is basically because of the assumption that a translation from customer needs a set of precise measurable specification is possible, and meeting the specifications will therefore lead to satisfaction of the customer needs. That is the fundamental premise we make, that if you can convert all the customer needs into specification, and if you can meet all the specification, then customer needs can be satisfied. So indirectly we are trying to satisfy the customer needs by measuring making the specification and then trying to achieve the specification. And to do that, all the needs to be identified and we need to list a metric corresponding to each need. So the first step is, for every need that you identify a metric which can quantify that need. Whatever may be the need, you need to identify some metric which will quantify the need of the customer. So that is the first step to be done in developing the specification. Yesterday, in the last class, we discussed a few of these. We will to develop the specification. Somebody says in the cycle design, comfortable ride. So that is a customer requirement. Customer says that it should be comfortable to ride the cycle. If you are to satisfy this requirement of customer, it should be comfortable. What metric you can find out, or how do we actually say that it can be quantified? Comfort. How can you quantify comfort? Any idea? So, if you are saying that it should be comfortable, what are we actually trying to tell when you say comfort? Less vibration. Yeah, that may be one point, right? It should not vibrate when I ride. So, vibration should be a metric. So, the amplitude of vibration or the frequency of vibration can be made as a metric. What else you can think of? Seat. Okay. So, seat means what? The seat height or the seat profile or the seat cushion, whatever. Cushion. Yeah. So, how do you convert that into a metric? Okay, so these are the things which we need to understand. How do we actually convert such needs into metric? Because it should be measurable also. We should be able to quantify it. You can say the thickness of the cushion or the amount of compression it can take, amount of load it can take. Whatever way you want to quantify, you should be able to quantify. So this is basically what we say the list of metrics. But when we do these metrics, there are few things which you need to understand. One is that the matrix should be complete. When I say matrix should be complete, what I mean is that every need, suppose you have needs 1, 2, 3, etc. I should have one metric, minimum one metric associated with each need. I cannot have a need which has no metric. Every need should have at least one metric identified. You can have more than one metric, but you need to have minimum one metric associated with each need. If there is a need without a metric, so basically we are telling that we don't know how to design for that. If somebody says that there is no metric for associated with that need, then basically we are telling, as a designer, I have no idea how to meet that requirement because it is not coming from the design, it may be coming from somewhere else. So that need I cannot provide in the design. Got it? So every need should have at least one metric associated with that need. So this is the requirement. The first thing, that metric should be complete. Every need should have a metric associated with that. Next one is, it should be dependent, not independent variable. So when I say that, it says that it should not be a variable which cannot be connected to something else. For example, somebody says it should be strong. Say the product should be strong. What could be a metric? Load bearing capacity. Yeah. Because load bearing capacity depends on many other things, right? The material, the thickness, and the way you assemble. How those things make. So it is a independent variable, right? But somebody says it is strong, it's a material. So you can use a steel, you can use plastic, you can use titanium, you can use some other material, right, to make it strong. But then material is not depending on anything else. When you say steel, steel is steel only. It's not depending on anything else. So it's a independent parameter. So you should not use independent parameters for metric. You should use dependent parameters. When it says the load bearing capacity, it is depend on the material, depend on the size, it depend on the way you assemble or you manufacture it. So it's a dependent variable. So every metric should be a dependent one. Don't take it as a independent one. Independent material is an independent one, right? So you say it should be attractive. You will say it should be blue color. Then it will be attractive. So you cannot say that blue color because it's independent of anything else. So it should not be. You cannot say that color is the only thing which actually makes it attractive. So should not use independent variables as matrix. So when you try to do this, it will be more clear to you. The best example is material. You cannot say material as a metric. Never use material as a metric for specification because it's an independent one. That is, metric should be dependent. It should be practical one. When you say practical, it means that you should be able to measure it practically. Something which you cannot measure or there is no way to measure it easily, that should not be used as a metric. For example, weight is a practical metric. You can actually measure it very easily. Surface finish can be measured to some extent. Okay, that will not be something which you cannot measure. Okay, so for example, if you take some products and you cannot say that the electromagnetic interference under zero gravity should be a metric because these things cannot be practically measured. So you should take something which can actually be practically measured. Under zero pressure or 30 bar pressure, this thing should be so and so. Yeah, these are not practically feasible, practically measurable. So don't take something which is not practically measurable. That is basically what you mean by metric should be practical. And in very rare cases, you can take subjective matrices. So something which I mentioned in the previous class, when you buy a Audi car, it is the prestige of owning a car is metric there. Prestige of owning a car is important for a customer. So in very rare cases, you can say subjective metric also can be considered. The ownership value is a subjective metric, but you can still consider it as basically saying that is a very important point. So the owner actually feels some pride on having a product. So we can actually quantify it in some sense, saying that very high, very low, very low, high, low, very low, like that. So in very special cases, you can consider few subjective metrics, but you should be able to say that how that can actually be utilized in the design. So these are the points to be considered when you choose a metric for a customer needs. Okay, one more thing. So the metric should be popular criteria for comparison in marketplace. So you need to look at what is the criteria used by others in the market. So try to use the same criteria here also. That is the popular criteria, so that you will be able to compare your product with other products also. So that is also an important metric. Should include popular criteria for comparison in the marketplace. So these are the things to be decided or things to be understood when you try to make choose a metric for a needs. And once you have these needs, what you need to do is to prepare a need matrix chart. A need matrix chart basically tells how the needs and metrics are related in a graphical way. You try to prepare this chart. That is the need matrix chart. Gives the relationship between the needs and metrics. So that is what is needed. At the end of this matrix, you will be getting the end of this analysis, you will be getting the need matrix chart. So we'll take few examples and then try to see how to do this. So take example of these needs: reduces hand vibration. Similarly, allows easy traversal of slow difficult terrain, enables high speed descents on bumpy roads, preserves steering characteristics, lightweight, easy to install, allows easy replacement, easy maintenance with readily available tools, safe in crash, lasts long time, fits a wide variety of bikes, provides stiff mounting brakes. So these are the
customer needs you identified, or we can identify for a cycle suspension. Okay, that's the cycle fork design which we discussed in the previous class. Assume that these are the customer needs you identified with its own priority. Now, the task is to see what are the metrics that you can identify for these needs. And as I told you, every need should have at least one metric. If there is no metric with one of these needs, then you are in trouble. You need to make sure that there is at least one metric associated with each need. So, tell me, what are the needs that you can identify? Let us start the simple one. Lightweight. Lightweight. What kind of metric we can use? Weight. Okay. Kilogram is unit. Metric is weight. Okay. So we'll say total weight or total mass, whatever it is. Weight. What else? Material. Who said material? Yeah. Is material a metric? Yes or no? No. Why material is not a metric? It is not independent, right? Because when you say material, you cannot do much. You take steel or you take aluminium or whatever it is, right? So it's not a dependent variable. So it's an independent variable. It's a parameter. So you need to choose something dependent, because when I say weight depends on material, weight depends on the dimension, weight depends on assembly procedure, number of parts, many things. So weight is a dependent parameter, so you can use weight as a metric. Is there any other thing which you can associate with weight? Number of components. Yeah, you can actually reduce number of components. You may or may not be able to reduce weight, but that may be a metric that you can use. So you can actually put all possible metrics. Sorry, number of components. Okay, anything else? So it need not be always directly related, because number of components, if you increase it, there is a possibility of increasing the weight. But if you, that's not always true, because depending on the size of the components also. So you can actually, this may not be always a direct metric, but it can be an indirect metric. This can be a direct metric which can be measured. Right. Easy to install. What metrics can be used? Number of components, number of parts, I will say, number of parts, tools required. I say special tools required. Yes, okay, whatever it is, you say tools required. What else? Method cannot be quantified, right? You have to see, you should say it can be quantified or not. No, but then method you cannot say, because then you should say what is the quantification of methods. So that's why it cannot be used. Yeah, you can say number of parts, number of steps needed. Yeah, number of steps can be a easy metric. You can say number of steps needed. Time needed for assembly. That's also an important metric, right? So time. So the time needed, number of parts, number of tools required, number of steps involved, all these can be a metric for easy to install. Right. Now, last long time. Last long time. So somebody says it should last very long time. What is the metric? Yeah, maybe life of the product can be a simple one, right? Life of product could be a product life or the useful life or whatever you can call, because it can be quantified. It depends on many other things. So product life may be a metric. Next, strength of material. Is it a dependent or independent? Strength of a material is fixed, right? I mean, for aluminum, you have a strength of material, steel, you have a strength of material. So it's all depending on that one only. So you don't have any variation there. So strength of materials cannot be taken directly as a metric. Okay. If you say load carrying capacity, then you can say that depends on many things, material, size, etc., etc. But life need not be always on life, I mean load carrying capacity. Another thing can be how can you vary the strength? No, that is not strength. Strength of material is a material property. Yeah, that's why. So what I am saying is that when you say strength of material, basically you are telling material. So material is not dependent. It's a dependent one. Yeah, but then you cannot change it, right? Because no, but then you have only options. No, you use steel or you take this, you will get different. So this life cannot be directly saying that okay, if you use steel, it will be highest life, or if you use this, you cannot get life. That way you cannot tell the life. Okay. So one important thing is it's a life in number of years and number of years or whatever. Another thing may be the warranty period may be an option you can say. And when you say the warranty period is 10 years, you have a 10 years life guaranteed, or it is 12 years, it's a 12 years guaranteed. So it can be a direct, indirect period, though it's not a question of design parameter. You can say warranty period could be a metric. Number of coats of paint applied. So what actually you mean? Why are you applying paint? Yeah, so you are talking about corrosion resistance, right? So why don't you talk like a corrosion resistance capability? Simple. Because you can apply paint or you can do something else also. If you are saying paint, then you are saying that only painting is possible, right? So you can say corrosion resistance as a thing. That actually depends on many things. You can improve the corrosion resistance by different methods. So corrosion resistance can be a metric. Pardon? Frequency of maintenance. Okay, yeah, that's also. Maintenance, frequency of maintenance could be a thing that is either coming under warranty, or you can say frequency of maintenance, number of maintenance required, all those can be part of last long time. Yeah, so like this, you can actually identify a metric corresponding to each need and make sure that for every need you have a metric. So this is the requirement in need metric chart. So what we are trying to do is having a need metric chart. So this will be what you are doing in the next class. You have identified the needs. Now you need to see how do you convert these needs into metric. That is the first step. So can you tell any metric for any of these? Because some of them may not be very familiar to you. That's why I am not asking you. Can you identify metrics for any other needs here? Okay, the first one has come. Reduces hand vibration. So we can say that a particular condition, what is the attenuation that you are getting in the vibration? This is basically a measurement of vibration. And maximum value from Monster. Monster is basically a test, standard test, practical test available. So you can do the test and then what is the value from that. And minimum descent time on test track. How much time it takes to descend on a test track. So these are the metrics that can be used to see whether it reduces the hand vibration. And if you identify some values for this, then you can say that if it is the descent time is less than a particular value, you can say the hand vibration is reduced. Or attenuation is this much, then the hand vibration is reduced. This is the way how you convert each of these subjective needs into the design specification or the metrics. So easy traversal of slow difficult terrain. So there are some standard tests for spring preloaded test or the spring preloads. So depending on the preload of the spring, you can actually get an easy traversal. Then again enables high speed descents on bumpy roads. very high subjective one, but then now we are telling what does it mean. If you have a handlebar dropouts, the attenuation, then you can say it is easy to do the descents, maximum value for the test and minimum descent time. So this the same metric can also be used. So you can repeat the metric, nothing wrong. You can identify these metrics, the same metrics can be used for this also. Preserves the steering characteristics of bike. Maximum travel with the 26, basically specifying that what is the steering that you can make with a 26-inch wheel and the rake offset, that is the offset from the wheel and the rake, that is basically known as rake offset. So a bit specific to that particular design, so you may not be understanding the thing here, but whatever you can identify from here, from these needs, you need to convert into the specification. So total mass, then time to assemble to frame, time to assemble, disassemble, special tools required, special tools required. So this safe in crash, there are standard tests for crash testing. So you have to use those tests and then see what is the value to be used for that. Cycles to failure, that is the testing. There are some standard tests available for checking the strength of the cycle or the capability of cycle. So that can be a metric. Then fits a wide variety of bikes, headset size, steer tube length, tire weight. These are the things which will affect that one. And lateral stiffness and brake pivots. So now you can see all these needs have been converted to metrics. Some of them may be very important, some of them may not. The metrics need not be all very same importance. Each one will be having different importance. You will see how to handle it later. But the most important point is, for all these needs, you need to have a metric associated with it. Any questions? Yeah, that we don't call just the strength of material. No, no. When I say strength of material, it is basically, you might have studied in your engineering mechanics, right? The yield strength. Okay, these are the things which we call as the strength of material. This is the strength of the component. Basically, the load bearing capacity of the component is what you are talking about, not the strength of material per se. This strength of component that you are talking about. Yeah, load bearing capacity can be a metric. That depends on the size and the material. You can change the material or you can change the size to get a different load carrying capacity. Okay. Any other questions? Okay, so finally, we will try to map these metrics to the needs. So you have first metric. So here you identify many metrics, and then you write down these metrics as here 1, 2, 3. So you identified 19 metrics, and some of the metrics are related to more than one need. And the importance of the need is also given here. So, sorry, this is importance of, okay, needs, yeah, nation from 1, 3. Now the units for each metric can be identified because you identified the metric, and therefore it will be having a needs, and it will be having a unit. Sorry. Any questions? Okay. So this is the metric, and these are the needs associated with the metric. So actually we put it in a different way. Initially we identified the needs and try to identify the metrics corresponding to it. We are identifying all the metrics here and telling that these are the metrics of importance to us, and these are the units of these metrics. Now the question is, what should be the value of these metrics? Each metric, attenuation from dropout to handle at 10 Hertz, what should be the value to make it may satisfy the needs of 1 and 3. So that is the next question, how do we get the value? So before going to that, we will prepare a need metrics matrix. This is known as need matrix matrix. So what we do, we write down all the needs here and all the need matrix here, and then try to identify how they are related. So for example, you have reduces vibration to the hands as the need, and you identified 3 metrics which corresponds to this. So we'll make this, and suppose you know that one metric is much more important than the other metric. For example, time to assemble. Time to assemble, you have many metrics. So one of the metrics is time. So I'll write it as time. Then the number of parts. Then somebody said number of steps. So now, if you know the importance, you can say that, okay, this one is most important, or this is not that important, and this may be important. So you can actually use different forms of representation, saying that this is the most important metric for this, and this may be not that important, or this may be very least important. So like this, you can actually prepare a matrix where you can identify the needs, the matrix, and how these needs and matrix are related in terms of its influence on the need. So which metric has got the highest influence on the need can be represented using different notations. So you can use a dark circle or a light circle or some other way to say that, okay, this is the most important one. If I change this, this will be easily controlled. If I change this number of parts, it may or may not, but there is a less influence compared to this, so I give it as a importance like this. And similarly, this one also, number of parts, number of steps, it may or may not, so it may be less influence. So I can actually identify this and then create a metric. Finally, I'll be creating a need matrix like this. So this need matrix involves the needs, the matrix, and the importance of the matrix to the needs. So this way, by looking at this chart, you will get a clear idea. If I want to make it easy to install, what are the things I need to change, and which one will actually make the change much more easier, which one has got the largest influence, least influence can be easily identified from here. So this is basically the purpose of having a need matrix. Got it? So this is an example. Okay, for the previous one, for the cycle, no need to worry, you don't need to remember this. Just for example, I have shown. So you can see that for each need, you will see one metric, at least one metric associated with it. Some of them will be having more than one, some of them will be having only one. For example, this has got only metric associated with it. Similarly, here there are more than one, and you can actually give the different colors or different representation to show which one is more important. So this is the matrix which represents the relation between needs and matrix. So the first step in identifying the specification is to get the need matrix. Any questions? Okay, so let us look at this from what we actually learned so far. So when we start the design process, we first try to understand customer requirements, and using a process, we identify the customer requirements. We go through the raw data. From the raw data, we convert to interpreted needs. From interpreted needs, we prepare a list of needs, which we call it as needs list. So we prepare a needs list, and we give the importance of each need also. And once we identify the needs, then we go to the next step. where we try to convert the needs into design specification. And design specification consists of two parts. One is known as the metric, other one is known as the, what is the other one? Metric and value. Okay, so every specification consists of a metric and a value. The question is, how do we get the metric? So what actually is a metric? So what is a metric? So basically the conversion of a subjective requirement of a customer to objective value, right? So that objective value should have something to measure, and that is what we call it as the metric. So what are the conditions to choose metric? Metric should be quantifiable, metric should be independent, metric should be complete. What else? Anything else? Yeah, it should be a popular criteria which can be compared in the market. So you should always choose a metric which is satisfying all these conditions, and subjective metrics also can be used, right? So choose a metric which satisfies these conditions, and then try to prepare the mapping of need and metric, and make sure that every need has got at least how many metrics? At least one metric, right? There should be at least one metric for every customer needs. Okay, and finally we prepare a chart, need matrix to list all the needs and metrics in a proper format, and then show which metric is most important for that particular need, which metric is the least important for that metric need, so that we know which one to change to get a which parameter to be changed to get a desired customer requirement. So that is known as the need matrix. Okay, so once you have these metrics, the next target is, or next thing is to get the value. So how do we get the value for this? Each metric, because we know the metric and we know the unit, we need to say some value for that. How do we get the value? How do you say time to assemble? You said it's a metric and you know the unit is seconds. How do we say that it is 20, 30, 50 or 60? Pardon? Measure. What to measure? Where do you measure? You don't have a cycle now. You are going to design cycle, right? So where do you measure it? So you measure from others. Suppose there is a similar cycle, you say how much time it takes to assemble, right? Or there is another, there are 2-3 manufacturers, they have different designs for the cycle. You try to measure how much time it takes to assemble. So you will get a comparison. Okay, they are taking 20. One company is taking 25 seconds, one is taking 20, one is taking 45. So you have an idea, okay, oh, these are the time taken by different one. So the customer is still telling it should be easy to assemble or time to assemble should be less. So what you will do? You try to either meet the current one or try to reduce the time from that, right? So this is known as benchmarking in identifying the value. So you benchmark your design or your metric with the is known as benchmarking. So benchmarking is you compare your metrics. So these are the metrics now. You compare these metrics with other products and then see how these companies are performing, how these products are performing, and then see whether you can use their values or better values for your metric. That is known as the benchmarking to identify the metrics or the values for the specification. Okay. So we'll discuss this in the next class. How can you use the benchmarking information in order to get the values for your matrix? Okay. Thank you.